a vector physics problem. Again, I made this one up. I've already put the list up of the exact question. But it says you're in the woods going for a walk. That's nice. And you move in 3 different straight paths. The first one is 200 meters at a heading of 22 degrees. Then you move 300 meters at a heading of 45 degrees. And finally, 500 meters at a heading of 120. So just a reminder, these headings, if this north and that's east and that's west, so that's 0 degrees. This is 90 degrees, 180 degrees. So that's our theta like that. Okay. So let's just sketch these 3 paths. But we want to find out how to get home. So imagine that we do this. So I'm going to start right here. Now I'm going to move 200 meters at 22 degrees. So that's going to be like this. And this is just a sketch. So this is 22. And that's 200 meters. Next, I'm going to move 300 meters at 45 degrees. So this is 45. And then finally, I'm going to move 500 at 120 degrees. So 120 degrees, that'd be like this. So this angle is 120 degrees. And that's 500. Now the question is, what's this distance? We'll call that RD. I want to find out what that is so I can get back to where I started. And in this case, what we can see is that if I add these vectors, RA plus RB plus RC plus RD, I should get 0. That's how I get back to where I started. Well, how do we add vectors? Well, the easiest way to add vectors is to write those vectors as components. If I write those as components, I can add the x's together, I can add the y's together, and I can find out what I want. So let's write these 3 vectors as components, because you could solve this. I could say RD is going to be equal to, subtract these from all the sides, RA minus RB minus RC. Or I could just add all those up and then take the inverse of it. And that's what I'm going to do. So I want to write these as components. For all of these, for A and B, I'm going to have the y component is going to be equal to cosine. The x component is going to be sine. For this one, what I could do is to say, if that's 120 degrees, then this would be 30 degrees, right? Because it's 120 total. And then I can use sine and cosine. So cosine would be x, and sine would be negative y. Okay, let's do it. I'm going to erase this picture because I need room. So I'm going to call this x and that y. Now I can say RA is going to be 200 times, again, the x component is going to be sine, right? Because that's the opposite side of that triangle. Sine of 20, did I say 22? Yeah, I used 22 in 2 problems. It's funny. Oops, it was just, I guess, thinking 22. 22 x hat plus 200 cosine 22 y hat. Let's just write those as numbers. So I'm going to get my calculator right here. 200 22 sine times. So this is going to be 74.9 meters, but let's write it as x hat. And then 222 cosine, 185. Now let's do RB. It's going to be equal to 300 sine 45 x hat plus 300 sine 40 cosine 45 y hat. So let's put that in. 300 enter, 45 cosine 212. 212 x hat. If you do it, sine 45 and cosine of 45 are the same thing, so you get the same thing. You can put it in your calculator if you want to. I don't really care. I care. I just am okay with you doing it either way. Now, again, for this last one, let me draw a picture. I'm right here. This angle is 120 degrees, so this would be 30. So this is going to be my x component. That's my y, but the y component is negative. Okay, so this is going to be equal to 500 times the cosine of 30 x hat minus 500 sine of 30 y hat. You actually could do sine of 120 and it'd give you the same thing. But I like doing it this way. So I get 530 cosine times 433. And then 530 sine times 250. So let's call all of these just R1. I don't know, you can call it whatever you want. R1 is equal to RA plus RB plus RC. So to do this, I just add up all the x's, I add up all the y's. Well, that's not so bad since I already have it all right there. So my x is going to be 74.9 plus 212 plus 433. I'm just going to drop. I got it all in there. I'm just going to drop it. Okay, so 74.9, 212, 433. And I get 719.9. And then I'm going to do the same thing for the y's. So I have 185 plus 212 minus 250. And I get 147. So that means that in order to come back to where I started, I have to go in the opposite direction of this. So what do they call it? RD is negative 719.9 x hat minus 147 y hat. And I said that would be fine if you enter it like that. But let's just do the magnitude and the direction of that. So if I want to find the magnitude of that displacement, the magnitude of RD, it's the square root of Rdx squared plus Rdy squared. It's just using the Pythagorean theorem. If I know the x and y components, I can find the total. So this is going to be the square root of 719.9 squared plus 147 squared. And I get 719.9 squared, 147 squared, plus square root 743.8. meters. Now what about the heading? Okay, so let's just think for a second. This is in the negative x, negative y, so I'm over here. And one thing I could do is to find this angle right here. I'll call that the angle alpha. And if I do that, then I can choose the x component as my adjacent, the y component is my horizontal. So the tangent of alpha is going to be equal to the opposite, which is going to be 719.9 over the adjacent, which is the vertical in this case, 147. So that means that alpha will be the inverse tangent of that. So I'm going to take 719.9, 147 divided by, and then I'm going to take the inverse tangent. And I get 78.5. But that's that angle. So if I want to do this angle, I have to add 180 degrees, right? Because I took it all the way over there. So heading is going to be 180 plus. And that's how to get home. So remember, for vector addition, it's going to help if you kind of sketch things out and then break it into x and y components, add the x's, add the y's, and you're home free.